Okay, now we should have audio, guys. Sorry about that. Okay, but yeah, stuff happens. This is live stream stuff, which is not tested very much, so I guess things happen. Okay, so recap from last week. We did look at rotary valves then very quickly, so went through the basics of rotary valves, looked at how those compared to like basic poppet valves, and what else did we do? Yeah, so we looked at single rotor, double rotor, disc type things. I mean, not in any great detail or anything. I mean, this is a live stream that is not prepared at all. I think it's more genuine to have sort of a unprepared live stream, to have more sort of interaction probably and stuff like that. And you could probably cheat a little bit by having some kind of a list done beforehand, but yeah, I think it's sort of more genuine and sort of more sort of potentially maybe interesting stuff, but also that brings with it a disclaimer that things we look at and go through, I mean, everything might not be accurate, and there might be things that I'm not taking into consideration, and all kinds of stuff like that. So yeah, please leave comments in the chat in case I'm saying something that isn't accurate or is completely outdated, or is just like doesn't have any basis in reality or anything like that at all, because don't necessarily know everything, and probably do make some reasonable assumption mistakes every now and then. But yeah, the point with this is maybe to like check out things reasonably quickly, sort of jump to conclusions, but in a sort of scientifically maybe based way a little bit, so that we're not just like spending lots of time figuring out every single detail, but like going through things sort of very quickly and trying to sort of quickly sort of ballpark things like, okay, is this better in certain situations or not, and if so, what might those situations be, and that's sort of the thing we're going for here with the tech analysis video stream stuff. But yeah, so without any further intros to that, let's get into stuff here. So poppet valves are these round. Oh no. Well, I could have prepared enough to like have just a poppet valve just show in my hand, but oops. Well, anyway, this is a Desmodromic poppet valve system here. So this is a rotationally symmetrical valve. So this part here. Let me just view this and zoom in a little bit so that we can check this out a bit better. Hold on, I need to move this so I can see what I'm actually doing here. Okay, I should have the camera set up here nicely. So yeah, poppet valves are these types of cylinders with a disc on the end, basically, or cylinders, something like that. And you seal at the edge of the valve here, and typically they will be round, but yeah, we already had an excellent question here by Joseph Caracal here. Like, do they have to be round? I don't think all poppet valves actually are round. I do think there have been like some Mercedes-Benz like 3-valve engines where I'm not sure if the intake or exhaust valve is like a larger and like a oval shaped, but I'm not entirely sure on that. I mean, maybe someone knows about that about details, but I mean, they can definitely be other shapes than round. But for like high mileage use, having a round shape that rotates around a little bit is very good, because if you have like some small like debris or other kind of hot spots created on the like sealing surface, and that will sort of like get evened out over like the whole area, so you don't like have one spot wearing away, and then as soon as you have like a tiny small amount of leak, it will just like increase and increase, and then that will sort of, once it starts getting to some kind of reasonable size, and will just like exponentially quickly sort of start eating away at that, and you have like a non-sealing valve. So that's why poppet valves are really beneficial, and also they do allow the combustion chamber to be very sort of well packaged, so you don't have any like crevices there and stuff like this, stuff like these interior shapes that create that have sort of a higher surface area to volume ratio, where your burn rate will go down, and you will start having like lots of like uncombusted or like higher ratios of uncombusted fuel there. With like extreme lean burn stuff, that's maybe not that much of an issue, but probably still is, because you always have some kind of small amounts of oil leftovers from the cylinder walls, and yeah, there. I mean, you can never have like a complete combustion. So yeah, like having a really compact combustion shape is very beneficial with poppet valves. So one of the big benefits to that. And poppet valves are of course not exclusively used on engines. So if we look at just like generic poppet valves, they're used on all kinds of like industrial applications and stuff like this also, which is so not that super important for engine use, but it's really good to like look at different areas to sort of figure out like what kind of uses might be beneficial for some types of technology that otherwise would be kind of difficult to figure out, like, well, would this type of valve work in this situation or not. So yeah, I mean, these industrial type valves, so if you need something to seal very well, then that's reasonably easy to do with poppet valve while maintaining like very high sort of pressure ratios. It's going to have like high sealing forces or like high pressure forces that still create like are able to create a really good seal. Of course, if you have like a particulate matter that you're trying to seal, then poppet valves are not very good. So then you need to have some kind of a different type valve system. But if you have like even if you have like reasonably large size, so if you have like a ball type granular material or something like that, I think you could probably use poppet valves for that type of a system also, because those would probably be like forced out between the sealing areas. But yeah, so I don't think we're going to go into too much detail about like industrial poppet valve things, because yeah, that's probably not what most of the viewers for this live stream are going to be interested in. So yeah, now let's look at the different systems. I'll just catch quickly up on the chat here and see what we have for what kind of suggestions we have here. Please talk about valve materials. Definitely a good suggestion. We will go through that. My biker friend told me about some bikes that have similar system due to high revs. It counteracts valve float. Valve stems and guides block airflow. Is there a solution for this? Okay, so interesting questions, definitely. So yeah, let's first go through the different types of poppet valve systems, and then we can go into a few and answer a few of these excellent sort of more detailed questions here. So Desmodromic valve system is the screenshot we have here. This is not the like most common. Let's just zoom in this so people on lower or on smaller screens can see what we're talking about here. So yeah, we have a typical cam. So this is what will be like a finger follower type opening. So this is like absolutely completely like traditional with like spring type valve systems also. So we have a camshaft here. So I'm looking at the opening cam here on the right in case you don't see the mouse cursor. And yeah, this rotates and pushes on a follower. And yeah, so this removes the need to have a bucket here. We'll go through that in a little bit further also. And yeah, this pushes the valve open basically. But then you need to be able to close the valve also. So Desmodromic systems have like a separate camshaft to push that closed. And this of course works. So yeah, you would think that okay, then you don't have sort of resonance frequency problems and mass inertia problems as much as with coil spring type valves, but that's not entirely maybe accurate, because I'm assuming you can probably make these Desmodromic systems capable of running to extremely high RPM, but there is a big problem with these. And so yeah, I'm wondering how to like yeah, I don't think I have any really smart way to like introduce this. But it's really like a sort of a optimization problem or like design issue mostly. So when you really start pushing parts as far as they will go, you need to take their flexibility into account, because when you're starting getting into inertial limits, then the parts that you're using, like this rocker here, for instance, or this finger follower or whatever, finger rocker or whatever they're called. So like this has inertia, and depending on where the force is that you're producing, so this is, for instance, a very good setup that will not have a lot of vibration. So you have like a contact point that is almost directly above the valve that you're like transmitting that force to. So there's like only a compressive force like between like a solid piece of metal or whatever material you want to use. Typically they will be almost all be metal, but you could potentially do this from other materials also. Other materials also. But yeah, so this is relatively easy to dimension. But then when you have the closing sort of rocker type thing here, so this gets much more complicated. You could potentially like move this around and have it closer, but yeah, having like a finger follower, we have like a cam lobe directly underneath here would be incredibly difficult, because that would like necessitate a really long valve so that you could like fit a lobe underneath, and then you couldn't like run a straight engine, because you could like have a lobe only on the side of the valve. So this like shaft really needs to be on the side of this valve here to create clearance, and that means you can't really run this type of a direct sort of a finger follower that we have on the opening side. So that means this closing part is going to have flex, and the higher RPM you run it at, the more flex you're going to be running into. And this creates really big problems, because you can't really do like FEM type stuff, because it's you need to do like time dependent like strength analysis to see like how this flex moves around. And of course, like having flexible parts is usually very beneficial, because there are multiple ways that you can benefit from the parts flexing. But that is yeah, it needs to like flex in the right way, because if you're flexing like you won't have like a constant force or anything like that. And even if you had a constant force, like you need to ramp in the force in some kind of way, and then yeah, the rotational inertia will affect that differently. So you need to do time dependent FEM like over the whole cycle, and then you need to, well, on the inlet maybe not so much, but on the exhaust you will also, well, actually the closing side. Yeah, okay, so on the exhaust part, okay, so yeah, probably, yeah, so you probably won't have much pressure difference actually when you're closing the valve. For highly boosted applications, I mean, you will have on the exhaust side, or potentially maybe on the inlet side also some kind of pressure differences, but they won't be really that big. So yeah, it shouldn't actually be that much of a problem. So it's mostly just inertial issues. So when you're really pressing down like really hard on this center lobe here, and this like L-shaped part is just like starting to bend over, and then when you sort of reduce the amount of ramp there, or like so reduce the ramp rate or something, it will start flexing back, and then you can like run into like a problem where the parts sort of start contacting each other, because you don't really want to have like dead areas or something like that, because then in that area you can have like the valve sort of bounce between the opening and closing cam, and that's probably not very ideal from a sort of longevity standpoint, because you really want to be maximizing the sort of accelerations like opening and closing, and the transitions between the opening and closing cams. But you still need to have some kind of clearance, because you can't have binding. So yeah, and these are, I think, I read some technical paper, I think that was like 2-3 years ago, something like that, where they were doing I think it was a doctor's dissertation, or whatever that's actually called, to look into a way of like a good way of simulating these Desmodromic systems at extremely high RPM. And it's not, yeah, that is still like a really state-of-art stuff, and I'm assuming you would need, yeah, with FEM stuff, that gets really tricky also to do like parallel calculations, unless there's been some like developments on that in that front. So yeah, I mean, time-dependent FEM stuff is something that takes a really long time to calculate. So yeah, I'm not sure, there might be some way to get around that and do some simplifications on the calculations, but But yeah, as far as I know, I mean, at least, so state-of-the-art stuff currently with Desmodromic systems is basically the flexibility of this, like a closing cam and how that interacts. And then if you have like a more complex opening cam solution with finger follower, then how like the flex of this whole system works together, basically. Because I mean, if you can figure that out and get that like optimized, then you can run these to extremely high RPM. You could probably compete with pneumatic valve springs also. But yeah, okay, let's look at some traditional coil spring type systems. So coil spring Poppet valve. Let's see if we can find some picture. Okay, so mostly industrial applications. Do we have any kind of car type thing at all? Okay, we do. Nice. Okay, this is really low resolution, but that should be fine. So yeah, this is okay, so this is actually kind of a good picture here. So yeah, so this is the traditional type that you mostly see. Well, traditional is maybe the wrong word, but the currently used most popular way to do this. So this also has a double coil spring. So yeah, a larger coil spring around like an interior coil spring. So with that type of a system, you can have like different natural frequencies and all kinds of stuff, where you have benefits of running 2 coil springs instead of 1 coil spring. You can do this also partly with like having a beehive type spring, so you don't have a constant radius, and you can have all kinds of variable pitch and stuff like this that will also help with that, so that the whole spring basically doesn't have the same natural frequency. That's kind of a way to sort of get around natural frequency issues. And these are like typically, so natural frequency issues are typically when you start like really maximizing accelerations and stuff, and you really want to run it as high RPM, as high valve accelerations as possible. So yeah, typically for like low RPM use in road vehicles, I mean that probably isn't an issue most of the time. But yeah, so we have inlet ports. We have the Poppet valve here. We have valve spring system here for the return part. Bucket lifter, so this is really good. We have a bucket lifter now, and the Desmodromic system we had that sort of finger type follower. Then there's also a roller rocker type thing, so it's basically the same thing as a finger follower, but you have rollers for the contact against the camshaft and for the contact against the valve, and you have varying versions of that also. So you can have a roller on the camshaft, but like sliding like a surface on the valve side, and then the other way around also. And yeah, this is of course depends on what kind of RPM you want to run at and what kind of longevity and stuff like this. So the higher the RPM, the more you need to focus on reducing the inertia and mass of parts. So that typically means like less roller components then. But yeah, so this type of valve spring, I guess there isn't really much to say. So one thing that would be really interesting to see if so with these like valve springs, so these springs, as far as I know, are like always solid, and that's not very efficient, because the coils in these springs, so they're like the main force that is transmitted through these is like this like rotational twist. So if you run a tube type spring instead, you could reduce the mass amount a lot, and still, so you could have a much higher sort of force per mass ratio in the spring than running these like solid springs. But I'm assuming this like is a manufacturing technique problem, like why these aren't tubes basically, because and well I'm not sure how you would like close the ends of those or something, but yeah, I guess you could probably like invent some way to do that. But yeah, the manufacturing stuff is definitely going to be the problem with that, so I'm assuming that's why we don't see sort of a tube type sort of a hollow valve springs instead of solid wire ones. But yeah, you have like a single coil, double coil, there are even like a triple coil spring return things basically. So these are all just for the return section. And yeah, when you start sort of looking at this bucket type lifter, and well, you have like this pocket here, and you have a bucket lifter here, and well, like, couldn't you just use like air pressure here instead? And well, yeah, that you can of course do that. So let's see if we can find a picture of that. So Pneumatic spring poppet valve. Do we? Okay, just industrial stuff. Let's see if we can find like pneumatic valve spring or something. Spring. F1 pneumatic valve spring. Okay, but do we have like a cutaway view of one of these maybe? I don't see one immediately, but okay, I guess we'll just go with something like this maybe. Wait, what? I want to zoom in. Hello? Come on. Okay, I guess this is maximum zoom in that we're allowed. Okay, so this is apparently a F1 valve. So when you start getting to RPM limits or acceleration limits, more correctly, that start creating like unsolvable problems with coil springs, then yeah, you need to move over to some better systems. So you can like optimize the ramp rates on the opening stuff, and well, I mean the closing ramp, of course. Also, you want to have sort of just barely contacting the cam lobe on the closing there, well, until you get, of course, to the like close to the seat, and you need to deaccelerate the valve again. But yeah, you need to. So yeah, if like really optimizing that still leaves sort of a power or efficiency or whatever it is you're targeting, or longevity or whatever, that leaves stuff still on the table, then you need to move over to some kind of other like a closing valve system. And yeah, the typical sort of thing that you will see are pneumatic type systems. So that means you basically just have a pressure area here underneath. You still have the like bucket or finger, or typically will be a finger follower, because that has the lowest amount of inertia possible, I think, of the current sort of normal solutions. And yeah, then you have just a pressure underneath to close the valves. And this is actually really efficient from all kinds of standpoints. So you can like vary the pressure rate and have all kinds of like pressure relief stuff and things like that. So you can have like kind of a little bit like non-linear valve action also, so that when you're compressing the valve, you can let out a little bit of gas depending on what kind of a pressure you want to be running at. And yeah, at higher RPM you can run higher pressures, and yeah, at lower RPM when you don't need a really high pressure, then you can just lower the pressure ratio you have there. So this like could potentially be very good for like hypercars or something like this, where you want like extremely high RPM capability, but you still want to have like a very good you want to be able to potentially do like 100,000 or 200, 500,000 kilometers or something on an engine. Then yeah, that you would be able to do that with a pneumatic valve system if you have a really good setup for that. Preferably also so that your control components and stuff like this are like don't end up being clogged by deposits or something like this eventually. So, and but yeah, I mean it is a really good system that has a lot of potential. Typically you will see like some kind of like small helper spring or something like that, so when you shut down the engine, then the valves won't like glide open, basically due to the force of gravity just opening them like over time. But I'm not sure, like probably F1 engines, probably the ones that, well, I'm not even sure, do the current ones even use pneumatic valve springs? I mean, they are really low RPM, so not really sure if they do that or not. But yeah, I mean, sort of for like F1 engines that do use pneumatic valves, of course, yeah, you just like hook up a pressure source and pressurize those, and then you can like have all the valves on the sort of cam lobes before you start up the engine. So that's not really a problem. And I think with you could maybe do that with street cars actually also. Especially with like the current sort of high capacity batteries, and especially with things that have some kind of mild hybrid system or something like that. So then you have enough energy storage, so you can like use some electrical power to pressurize the pneumatic system, so then you might get away with not even like not needing like any kind of like even small helper springs or anything like that there. But okay, that's the pneumatic stuff. What else do we want to look at? So opening mechanisms, well, we do have the push rod stuff, of course, direct acting, so you have the bucket type things, finger followers were already, so yeah, finger followers will be like these type of valves, or like a valve systems. Then we can have rollers on those. I think these are pretty straightforward, so we don't really need to look at those that much. Oh, we do want to, let's wait a minute, let's see if I can, let's see if we can do find a two-stroke. So yeah, some two-stroke engines actually do have poppet valves. Let's see if we can find some of those. Let's see if we can find a... Ooh, this might actually... Okay, well, we don't really have a very good cutaway from this, but... So yeah, some two-stroke engines also, so typically these will be in like extremely large like energy production, or like big, like really big ship engines. So where you run a two-stroke engine, and you have the inlet port here at the bottom of the piston, so, or the bottom of the cylinder, so you can see here the pistons below this inlet port. And then at the top, of course, you don't have there's no piston there to like open the exhaust port. So then you run a poppet valve for the exhaust system, and this is actually really beneficial, because then you can have the exhaust so that it isn't like symmetric in relation to the compression, and but yeah, so it's not symmetrical in relation, or doesn't necessarily have to be symmetrical in relation to the like a piston up and piston down travel. So that is really beneficial with having like a poppet exhaust valves in a two-stroke engine. And you might even like potentially have some benefit of this on running at like smaller engines also. I haven't seen that though, so I'm probably isn't really used that much, but yeah, I do see definitely the potential for that. So yeah, might definitely be some use for this. And yeah, with these type of systems, so you have like these insane stroke to bore ratios. So I mean, this is I mean, I'm assuming this is actually like pretty accurate. So this might like even be from some like real CAD file, and not just some like artist's impression or something like that. So yeah, you can like have bore to stroke ratios of like 3 or 4 or something like that, and yeah, then you just like flow intake air through there and just flush the whole cylinder basically, and yeah, time the exhaust to close correctly, so you're not wasting energy there. So yeah, this is a really interesting way that poppet valves are also used in, and then you can like get away with having like one single poppet valve in the cylinder head basically, and yeah, you have the exhaust ports here up on the side. So this is a really interesting use of poppet valves also. Were there anything else about poppet valve, like basic stuff I wanted to go through? And check the time also. Okay, so we have been going for, oh wait, I need to check. Okay, so we are just coming up on 30 minutes now. Okay, yeah, I need to try to keep these relatively short, because otherwise they don't really work as standalone videos. So yeah, sorry about that. But yeah, I need to think, was there anything else that could be beneficial to go through? Not really. I think these are probably the sort of basic stuff. Okay, so let's go over to do some questions here. So yeah, feel free to oh wait, there was, oh yeah, so there was a poppet valve system that someone suggested last stream. Let me just check what that was. Open source free valve type. Yeah, okay. So some Wesley Kagan. Okay, let's see if we can find that. Wesley Kagan. Miata concept. Let's see if we can. Okay, well, this is. Not um, okay, do we have like some Wesley? Okay, it's maybe not Wesley Kagan, but Wesley Chapel, maybe? Let's see, can we load up this web page or not? Okay. Yeah, I don't think that's what we were looking for. Oh no, Keegan. Okay, Wesley Keegan. Okay, with 2 E's. Okay, so just a mistype there, I think, by the yeah, comment from last week. So do we have some better? Okay, maybe not. Let's see. Freevalve. Oh, valve. No, valve. Okay, this is kind of difficult. Okay, I'm hoping this is. Well, we don't want. Well, we're actually blocking them, so we can just like pretend to accept everything. Fitted with Koenigsegg's freevalve tech. Supposedly like a open source freevalve Miata concept. He's tried to do similar system as Koenigsegg in his garage. So okay, Wesley Kagan. Okay. Okay, yeah, I was just Wesley Kagan. Maybe this is better. This YouTube is building. Okay, this sounds much better. Okay, so does he have do you guys in the chat know like what's the best source to find some like drawings or something on that? Freevalve MX5. Okay, we can do that. Okay, so I'm guessing. So this is probably the same stuff basically. Let's see if we do have. Okay, there's not too much content in there. Okay, again. Freevalve MX5. Well, okay, let's go for. Let's look at this. So yeah, oh yeah, so Poppet Valve. So yeah, one of the interesting things about this is of course valve timing stuff. So that is yeah one major thing that would be good to go through. Thoughtspeed.com. Do we have like some like technical explanation of this stuff? Because I don't think like these type of media are going to have like really good technical explanations of how these things work. Use pneumatic actuators for the valve, make it more efficient. Yes. Some other machinery tech. Okay, so I'm assuming this is probably not free valve stuff because I don't think they're going to be able to license this. So I'm assuming this is just like a free valve competing tech or something like that. Koenigsegg free valve tech is part of. Okay, so that's part of the Koenigsegg stuff. Yeah, so you can definitely like. I mean, you can reach 50% fuel efficiency with yeah spark ignition engines. That's well, I don't want to say that's not really a problem, but it has been achieved, so it's not impossible or anything. So you don't really need free valve for that. But what you can do with free valve is to like way like broaden the operating range of the engine while still having it extremely like efficient in like areas. So you can like finely tune the engine to work at a very wide operating range. That's where the main benefit is really. Okay, so this guy has his own stuff. Okay, well, no, do we? 25 minutes. Yeah, we don't have time to check this, unfortunately. But let's see. Oh, he does have... Okay, nice. Hopefully he has Instagram, Patreon. Okay, so he doesn't have a website, unfortunately. Okay, so we'll probably need to check like YouTube videos then to figure out what exact type of technical stuffs he's using to yeah, run this system with. Yeah, okay, but we can like generically talk about valve timing and stuff like that anyway. So let's see, can we find Babel? Okay. So how do we find valve? Oh well, so we probably need to find a camshaft manufacturer. Camshaft duration. Let's see if we can find some kind of low profile. Okay, so this was what I was looking for. Okay, so okay, yeah, this video looks good. So yeah, with the sort of a free valve type system that Koenigsegg have, so that's as far as I remember, so that's like a electro-pneumatic hydraulic system that they're using on Koenigsegg. So they probably have electronics to control everything and operate some valves or something. Pneumatic stuff, so I would assume, would they maybe have pneumatic stuff as like the return spring maybe, and use hydraulics as the like opening force, or are they using like or are they using like hydraulics or pneumatics as like a pre-valve for the like main function or something? I'm not really sure how that is. I mean, there are probably patents available where you can yeah, check what their solution for that is and why they're using electro-pneumatic hydraulic system. But yeah, okay, CNET has a picture of his camel. Okay, that's good info, guys. I mean, yeah, what could I do without you guys? So thanks, John Newman. CNET freevalve X5. No, this is not what we wanted. Yeah, what was that? Wesley Kagan. Okay, whatever. We're not actually accepting those anyway. Okay, wait a minute. So are we? I want to open this, but how do? I'm at the right place here. Okay, so derp is super nick there. Pneumatic used to operate the valves on the Koenigsegg Tech. Drive YouTube channel has a good interview about this. Okay. Pneumatic is used to operate the valves. So do they have electronic like solenoid control for a hydraulic valve that then opens a pneumatic valve? Because I do remember them being quoted as saying that it is a electro pneumatic hydraulic system, and I mean, of course, to operate with any kind of ECUs or stuff like that, I mean, it has to be like electronics has to be like the end control, but to using like really high sort of forces and energy levels with electronics is not very practical. So that's why you want to use like high pressure hydraulics or pneumatics or stuff like that. But high pressure pneumatics is problematic because then you have higher energy losses, because when you're increasing the pressure of a compressible or well, all fluids are compressible, but like fluids that compress a lot, or you're losing so much energy during the compression, that you don't really want to run something that is like a purely pneumatic, because you have a, unless you can like recoup that energy on the expansion, then you're losing a lot of energy basically. So yeah, your fuel consumption goes up or something. You're wasting energy in compressors and stuff like this. So you don't want to run something like purely pneumatic typically. Okay, but that's they actually have a sub 9-5 operating. Yeah, so they definitely have. I think they have some like demo engines and stuff like that also, and yeah, definitely are some videos available, but I haven't like really gone into the fine details of how that Koenigsegg free valve stuff works. I did see like one engine that they do have running. It's really big. I'm not sure if this is like a final version. They haven't been able to like minimize the construction well or not, but it is really big compared to sort of a traditional like cam type valve train stuff. The F1 version is the part that contacts the valve. F1 part is the part that contacts the valve to actuate. Is it fluid or gas? No. So with F1 type, so with the pneumatic valve springs, so when you're talking about pneumatic valves, the valves are actually not pneumatic. They're like traditional poppet valves, and you have a cam lobe that opens those. It's only the valve spring that is pneumatic. So you don't have like a coil spring, but you have a pneumatic spring instead. So you have like just an air pressure that closes it, and you need to have seals on that, and like pressure control valves and pressure adjustment stuff and things like this with the F1 type things. So that is like, yeah, when people talk about pneumatic valves, I mean that's completely wrong. There's not, they're not using pneumatic valves. They're using pneumatic valve springs. But yeah, I mean it's with like all kinds of tech stuff. I mean people like misrepresent like things so badly that yeah, it's unfortunate. But what can you do? Okay, but let's say go through some of the other stuff here. So yeah, if derp or someone, if you have, yeah, I wasn't able to find here from CNET like a drawing with the CAD stuff on this free valve stuff. That is actually extremely interesting. That would be nice to see, but I unfortunately wasn't able to find that. So it might be in, I mean, the YouTube videos probably have that information, and like I highly recommend visiting those, of course, if you're interested. But yeah, let's look at some of the other stuff. So yeah, materials. Let's go back to oh boy, we have too many tabs here already. Oh yikes. Where do we have valves? Okay, yeah. So materials of these valves are, yeah, one of the interesting points also. And these are like material tech stuff that is actually kind of important. There are like multiple solutions now to use, so it's very easy to sort of like, yeah, just get something off the shelf that will work nicely. So specifically, David Bayliss was asking specifically about Inconel titanium sodium filled stuff. Okay, so Inconel is really good for high temperature stuff while still maintaining strength in the valve. And I'm assuming this will probably reduce the tendency also of like pitting. So when you have like so if you have a fuel that has tendencies to like produce carbon deposits or something, so if you have like carbon deposits on the seating area, then you can like very easily have very, very high temperature sort of small spots, and then you can, when the valve closes, you can sort of start building up issues with that by having very high temperature areas there. So I mean traditional gas, especially if you're running really rich, will have these types of problems depending on what kind of temperatures you're running surfaces at. But yeah, Inconel valves are really good for high temperature stuff, so like exhaust valves typically, unlike racing engines, turbocharged engines with anti-lag or low compression engines where you have like higher exhaust gas temperatures. So this is something that is good for that. Inconel is of course very heavy, so not really ideal for really high RPM use. Titanium stuff again, so titanium is theoretically good at high temperatures, but it's not as good as Inconel actually. And I'm assuming the titanium does get sort of like the stiffness of titanium goes down when the temperature increases. So you want to, I could probably try to dig up some curves somewhere, but yeah, we're not going to get into material tech too much. So titanium will typically be used because the density of titanium is lower than iron-based alloys or nickel-based alloys that Inconel is. Then yeah, you can have like the sort of same volume of a valve but lower weight. So running larger valves, higher RPM, that means you have more benefit of titanium. So you'll typically see like intake valves on motorcycle engines and stuff like this will be titanium. And the exhaust valves, depending on the temperature, you might be able to run titanium. I'm not sure the durability. You might be limited on the exhaust side and not be able to run titanium valves there. I'm not entirely sure. I mean, there might be some alloy of titanium that would work there for like short durations like drag racing. But yeah, you probably might need Inconel or stainless on the exhaust side. And then of course, yeah, sodium filled is like the sort of ultimate badass of cooling valves, basically, especially for race engines where so yeah, you have this like large flat surface area in the combustion chamber, so that receives a lot of heat, and then you have the exhaust gases like flowing past the valve. So there's basically like no cooling at all. Like the intake valve has a much better time because yeah, the combustion temperature is the same, heating the inner surface of that, but then you have the intake charge coming in, and that is much cooler than the combustion gases. So we'll have a cooling of the intake valve, and that typically means that yeah, you don't have any problems with that. So we will be able to transfer enough heat from the valve dish on the valve seat into the cylinder head to not have issues. Oh, we had a slight cutout here with the video. Hold on, guys. I'm just checking that we are okay. Okay, we should have dropped frame 0, and YouTube is saying that we are having excellent connection. Okay, so should be good. So where were we? So material stuff. And temperature things. Okay, yeah. So exhaust valves don't have that luxury. So you need to, yeah, be able to either run a much wider valve seat to be able to transfer more heat from the dish into the cylinder head, but that's not ideal on racing engines because you need to maximize your sort of a flow area on the exhaust port in relation to the cylinder, or then you can just run a smaller bore instead. So you don't really want to run a wide valve seat. And that basically means, yeah, the options that are left are then to transfer the heat through the valve guide, and there you have a really large surface area. Of course, you don't have direct contact there like you do have on the valve seat, but because you have a much larger surface area also, so that is very the benefit of running sodium-filled valves. So these will typically be like Inconel sodium-filled valves. I know they have been in like older turbocharged cars like Volvo 8 valves and engines and stuff like this, so they have had sodium filled valves, and they probably are not Inconel, I would guess, at least. So yeah, you do see those, but they are, so manufacturing of sodium filled valves is being ramped down now. I don't think, last I checked, you couldn't even custom order sodium filled valves anymore. So just like the designs that are already there and the sort of manufacturing setup that is available, yeah, Supertech at least, I think there are probably some other manufacturer that also make these, but they're not doing new designs anymore, they're just using the current ones. So I'm assuming that's because like the Inconel alloys are like good enough already, so you don't need to use sodium filled stuff. But it's still, the sodium stuff is still better. So if you're running extremely high exhaust temperatures, so rallycross stuff, things like this, where you're running continuous, very high exhaust gas temperatures, then yeah, sodium filled stuff, I mean, will give you higher margins definitely. So, but that also means that you're transferring heat to the valve guide. So you need to have like the clearances for the valve guide correct, and you need to have cooling around the valve guide also, so that the valve guide doesn't end up overheating, and yeah, all kinds of things that need to be taken into consideration also. But yeah, those are the sort of material things. Maybe I rambled on a little bit too long about that, but yeah, things happen sometimes. Some bikes have a similar system due to high revs. Okay, yeah, I think we talked about that already. Electromagnetic actuators for springs. Okay, so so using, Oh wait, so Joseph Crack also asked a little bit earlier in the stream, why not use electromagnetic actuators for springs? So the springs are for return, and then for the actual actuation, you have the cam lobe, or the current technology for that. So doing that with electronics is a problem that of energy density. So with electronic components, really high energy density is a big issue. I'm not sure if you could run like some type of like railgun type thing to maybe open the valve or something, but yeah, it might be difficult. I mean, I'm not that good with electronic stuff, to be honest, so I'm not entirely sure. There might be some way to do that where you could like directly electronically operate valves, but yeah, it's I mean, currently, at least with the tech that is typically used, so it's simply like an energy question, because yeah, you have some mass in the system, and to be able to accelerate that quickly open, you need a high power input. That basically means, yeah, you need lots of energy in a sort of as light weight as possible. That ends up, yeah, creating a big problem, sort of electronics wise. So yeah, using mechanical stuff, that basically, yeah, you're at the sort of mechanical limits of materials then, instead of sort of needing, you always need to be within the mechanical limits, but in addition to that, you want like as few other limiting factors as possible. So yeah, but I think I'm not really sure, like we need to look into the electronic stuff a little bit more to figure out if there is some way to get around that, so that you could run like a full direct electric, like a valve operating system. But yeah, sometimes something to take into consideration. You also need to see like what kind of like where are the, okay, so these basically, so when you have like a really quick acceleration on the valve, you still like you still will have like some kind of a shape like this. I mean, you can't have like just a like direct opening and then like a flat area and then like close it quickly, because like parts have inertia, and if you're running those at high enough RPM, then yeah, it's not really possible to do like this type of a like direct opening thing that you hear like Koenigsegg guys and stuff like this talking about. Of course, they are talking not about extreme RPM race engines, but more like street engines. And for those, that makes sense. So you could have like a like completely different shapes to these openings, as long as your valve train components aren't like taking a beating and will like reduce the sort of longevity because of running these like really high acceleration peaks by having these like lift curves that are like have sharp corners or something like that. But yeah, and it's not really actually that limiting. So when you're running simulations with sort of a traditional type cam lobes, you will definitely have benefit of running like harder accelerations on the opening and closing ramps. So that is definitely beneficial. But otherwise, I mean, to be honest, it's not really that big of a gain, because there are like currently technologies where I mean, you can have like a variable cam timing, well, so where you time like the camshaft variably in relation to the crankshaft. So basically, you can yeah, move the intake and exhaust like lobes sideways or overlap more or less, or move both in a direction. That's very beneficial. There are variable lift technologies also, so BMW has used those for I think 10 plus years now on series production engines with variable degrees of issues also. But I mean, yeah, I mean, still production engines with yeah, multiple years, so they work really well, and there are technologies for that. There are also technologies for variable valve duration, and so yeah, you can like theoretically combine all of these to have like a full mechanical system with a coil return spring, and have a variable opening, variable duration, and variable timing. So that basically like already gives you pretty much everything you could want to do with like a full free valve type system. So then it's just a question of which system will allow you like benefits overall for the engine, like how much investment in research and technology will that be, and what kind of series production stuff or production costs will there be, and what kind of yeah, size-wise, like is it going to be really big and bulky, what kind of efficiency is going to consume more or less energy. It is really difficult to make a system that is more energy efficient than using camshafts and yeah, just traditional return springs. So that is also a big consideration to look at. Okay, let's check a little bit more about these chats here. Does Thor have sodium-filled valves? It depends on. So for our Thor engine, it depends on the use case. So because we do billet parts, and I mean each one is designed specifically for the customer. So for the ones in the RP968, for instance, it's just a circuit racing spec. So that's 1,500 horsepower only. I mean, it is a lot of power, but compared to sort of the engine's capability is not really that much, and we don't need to run like any high boost pressures and don't really need any anti-lag and stuff like that. So it's just running a plain stainless valves actually on the RP968. So yeah, that's also one of the benefits of like doing like good designs. Otherwise that means that in certain areas you don't really need to be pushing everything absolutely to the maximum. So yeah, it's cheaper, easier, more lightweight components also, so less wear and tear and all kinds of other components. So yeah, with like sodium filled or Inconel exhaust valves, for instance, the mass of the valve goes up, so that ends up wearing more on the or like reducing the longevity of the components also. So yeah, on the RP968, it's a stainless valves for drag racing specs, so 3,000 horsepower. I would say maybe at 2,500 RPM and up for drag racing, I might want to recommend sort of Inconel or sodium filled valves. I don't think there are sodium filled valves available that big though, so I don't think that's actually an option. So might need to do Inconel valves in that case. And on the Thor engine, so for rallycross use, probably even at 1,500 horsepower, probably even lower, probably at like for rallycross use, probably even from 1,000 horsepower up, you would probably want to move away from stainless valves and go to Inconel valves instead, to give that like extra heat durability. I hope that answers your question, John Newman. Feel free to specify more if you want to. Just take the Koenigsegg video. Okay, derp. Solid research here, like live research. So this is really like a community effort here. I love this. Okay, just check the Koenigsegg video. Pneumatic is used to open the valve. Engine oil is used to keep it stable, and either steel or air spring to close the valve. Okay, so that's really interesting. So they're using like pneumatic. Okay, so they have like electric control of a pneumatic like a valve to open a pneumatic valve. I'm assuming to like have some metered amount. So they probably have some pre-chamber with like a specific amount of air at some specific pressure. They open a valve to allow that pressure probably then into the pocket, like actually opening the like poppet valve then. And then you have then you have a hydraulic system to dampen that movement and stop it at the desired height. And so probably need to have stable and then either steel or air spring to close the valve. That's actually kind of interesting. So if you just have, so what's actually dampening the closing part then? So I'm guessing so they probably have like a so they probably have a hydraulic damper there. So use air pressure to open the valve, and then another air pressure section to close the valve, and then have a hydraulic system to like dampen that movement and slow it down. Because if you're just closing the valve with air pressure and just slamming it closed, then that's going to like destroy your valve train very quickly. So I'm assuming they have a damper on the closing section also. I would think, I mean, that does sound like it's very sound like fundamental technical stuff, so I don't think like the basics would have changed very much, but probably like how the valving works and if they're like using pre-chambers, or if they're using like direct feed from a valve from just a large like pressure source or something. Probably have all that kind of like technical details on how to actually make it work and be as reliable and as economical as possible is probably what they're developing. But that definitely sounds like a very good sort of solution, because yeah, I do think that with pneumatic stuff you can probably get like higher sort of power density than with hydraulics, because you have so much viscosity with hydraulics that if you're trying to like open a valve very quickly with hydraulics, then that might be difficult. I mean, you can use a very high force over a period of time to like have really good power density with hydraulics, but doing something like extremely fast, then the viscosity will end up like creating problems. So it does make sense to do that. Okay, excellent research there, derp. Very good. And yeah, thanks for letting us know, and yeah, other people probably expect that hugely. Didn't expect you just to be running stainless valves in RP968. Okay, considering the levels of customization of the engine you build, price of the engine mixes. Yeah. So of course, I mean, there are always more expensive stuff and things like this to do, but I mean, this is not like a €1 million engine or something like that, where you have like everything is like absolutely the most expensive stuff you can do to just like get these tiny gains. So the Thor engine is still incredibly economical, and we need to like be able to save costs wherever possible. I mean, it still needs to be like the best performing and having the like best power to mass ratio, but it also needs to have like power to mass ratio to price ratio. So we don't want to run stuff that is more expensive if there's no benefit of that. And in the case of the RP968, so running in-canal valve exhaust valves, for instance, would increase the weight of the valves, but it wouldn't improve the performance of the engine at all. So you just end up with lower durability, so more wear and tear, more expensive to get things reseated, and there's no upside of that at all. So yeah, we don't want to run something that is just because it's more expensive. It needs to be actually beneficial for and not only for the engine overall, but for the actual use case for the engine that is going into. So that will heavily influence the selections of material and all kinds of components, of course, also. So what kind of camshaft we're running, what kind of bearings we're running, and yeah, this is also something that we take into consideration with our Rex engine and stuff. So bearing material selection is, for instance, actually something really interesting. Just going really off topic here from Poppet Valves, but so like sort of low performance bearing materials are typically like really soft, but they are very tolerant of contamination. So if you have like engine components fail a little bit or something, then if you have really soft bearings, then those sort of particles, you can embed those in the bearings and still run the engine. And as long as you maintain like oil film, so that your oiling system is working correctly, and you don't like run it, so when you have like oil feed in different locations into a bearing, so you don't like sort of run it progressively dry before the sort of next oil input feed. So then yeah, you can sort of run like cheap bearings might be much better than sort of really high performance super stiff bearings that you see on some engines, because then those will be very intolerant of particulate like on contamination and stuff like this. So you don't necessarily want to run like more expensive parts if it's not overall beneficial. Okay, so anything else interesting to look at here? I think valve timing stuff probably, we did go through that very quickly. I don't, do I have maybe anything else to add to that? Probably not that much, really. I mean, I definitely think like the free valve type stuff, and yeah, whatever technical stuff this what oh, I forgot what is this guy's name. I want to like quote him correctly. So oh yeah, Wesley Kagan. So yeah, whatever system Wesley Kagan is running, I actually need to look into this because it might be really really potentially interesting. It does look like, based on this picture here though, it does look like it's very very large, so might not be very wait, where's I can't I want to scroll this. Okay, oh well. No! Okay, so yeah, these look really, really big. So for a race engine where you want to package everything as tightly as possible under some hood or something, then that makes this kind of yikes. But I'm not sure. I mean, it might be possible to reduce the size or package it more efficiently or something like that to make this work better. But of course, yeah, a tech demonstrator and proof of concept is not the same thing as like a fully optimized thing that is like sort of performance or production ready or something like that. So yeah, I mean, definitely don't want to say that this is not going to be very good. But yeah, if you need to run a system like this with some rocker systems, that apparently is what they have here, then that ends up adding so much size that for racing use, I don't think this system is good unless it can be like minimized or packaged much more efficiently or something. But like even packaged efficiently, because it still takes up so much volume. So if you have volume, then you can't really package volume any better. So that's a slight problem. But yeah, it might be better to yeah, be able to yeah, but I mean, I don't know. I mean, it might be possible to like increase pressures or something and run smaller components and stuff and run sort of a more direct stuff and get rid of some of the rocker stuff, or I'm not really sure what the technology there is. I'm assuming that some of these are like opening things and the other ones are closing type units, and then we have like a rocker operating here, and then this is like the actual valve here somehow connected to the rockers here on top or something. Yeah. But this actually does seem really interesting, so we'll need to look into that, and yeah, I might come back to that if we do more episodes, then return to this topic and look into this in a little bit more detail, or like do actual like a YouTube video like going through the tech stuff in detail. So I want this to be like a live stuff, to just go through stuff at the same time as you guys, to go through things very efficiently time-wise. So really nice, and yeah, getting some solid stuff here. Koenigsegg freevalve actuator looks size-wise similar to a bucket valve lifter. I have seen some renderings of the, or like pictures of the actual engine that the freevalve engine that Koenigsegg has, and that sort of a cylinder head on that is massive. It's much bigger than what you would have on like a normal camshaft type thing. So I'm not sure if they have like been able to develop that further and minimize stuff more or something. I mean, one of their benefits that they were claiming initially is that yeah, it's like much more compact, and you don't need like a camshaft drive hanging over the end of the engine and stuff, which I mean makes total sense. But if their components are so large that it's still bigger anyway, then that doesn't really work. But yeah, I mean, yeah. So derp, yeah. I have seen like their concept stuff and like basic drawings and stuff like this, like the components. So they are very small and compact. But then the parts, like actual complete like running engine, is really big and takes up so much more space than like even like variable valve train stuff that need all kinds of extra like moving parts in there. So yeah, I'm not convinced on that yet. I mean, if they are able to minimize that and get the parts much more efficiently, or I may be out to date on that also, that's entirely possible. But yeah, could be interesting. But yeah, definitely. I mean, if that okay, so YouTube is having some problems with the video. Wait, no, so we still have 0 dropped frames, and YouTube is saying that our connection is excellent, but it's still not loading all the time. Okay, I have no idea what YouTube is doing there. Okay, band sits directly on the top of valve, no rocker in between the actual. Yeah, I have seen that. So yeah, the Koenigsegg system does not use any rocker type things or anything like that. So that is definitely a yeah, potential benefit. And there are also like other benefits that Koenigsegg is planning on using. So like having 2 exhaust valves, so they have like one exhaust valve goes to the turbocharger, and the other exhaust valve just goes into an exhaust system, like directly bypassing the turbo. So then you can run at different load conditions. You can like vary the lift on like how much turbocharger do you need or don't you need turbocharger, or like this is potentially very beneficial. Also things that you can do. But again, this starts requiring like a more, so if you want to vary that a lot, then you need sort of a more valve area per sort of displacement. So you might end up needing to run a larger bore stroke ratio, which, yeah, again, well, your combustion efficiency goes down a little bit because your combustion chamber gets like flatter and wider instead of more round. So there are like trades off with that system also. I forgot the video of that 9-5. It's been built on top of B235 engine, and the valve covers it's lower than on stock engine. Okay, so they seem to have probably done that. Yeah, I'm not sure if I can like watch videos here. Might be taken down taken down because of some like copyright stuff or something like that. I have no clue how that copyright stuff like works in practice on YouTube. So valve cover is some fancy bullet part which has channels for pneumatics and throttlers. Yeah, I mean it entirely makes sense to have like the valve operation stuff like incorporated into the cover if you have that type of a system, so you don't have like the system built underneath and then have like an extra cover on top. That is just like a extra part basically. So okay, that is really interesting. I mean, I do think, I mean, if these type of entirely freely usable parts, so like Koenigsegg, so if they like actually can build those systems, this is actually really interesting. Okay, let's okay, screw this. It will take extra time, but okay. Let's look at this. So freevalve 9-5. Let's see if we can find this. Images. We're already running. So it's this may be one of the so derp, is this the one of the engines you were referring to? Okay, but this well, I mean, this actually does not look much larger than what you could do with the like traditional like cam type system. I'm not sure why Koenigsegg would be testing this on a Saab though, because they have like their own concept and testing engine and stuff. Okay, so this is the one derp was referring to. Okay, yeah, so I think we could definitely look at pictures here without getting closed down by YouTube. Now we still do have this like large section here in the end though. I'm not sure if this is like some pressure tank thing or something. But yeah, I mean, I do definitely think that there is a big like potential benefit to use this stuff, and definitely want to yeah, keep tabs on that system. But if it is more like energy efficient than using mechanical systems, is yeah, I think I would need some convincing on that, because it depends a lot. I mean, in relation to running in super stiff valve springs, it could probably be doable to run this with like a similar energy loss. But if you had some kind of a variable valve spring system, so like a pneumatic valve spring system or something like that, then yeah, in that case, I don't think you can have like a free valve system get anywhere near to the energy efficiency of having like a mechanical opening and a pneumatic valve spring, because you can vary that by engine RPM and load to like minimize friction losses. So I think you're always going to have way more losses running this type of a system. But of course, the more sort of you can move over to electrical stuff, then you might be able to yeah, gain some of the efficiency. Well, no, you're still not going to be able to do that. So unless you have like a plug-in hybrid, so you can like cheat and run the electric system off coal plants instead. But yeah, then of course you're adding batteries on the car, that adds weight, and yeah, not ideal from a performance or fuel economy or like yeah, fuel, like overall like global fuel consumption point of view. So definitely don't want to be adding extra weight to the car unless you have a huge benefit of that. Okay, but this is actually like really interesting that they're running this in a test setup. Camless engines, position sensor. Oh, okay, this is kind of interesting. Pneumatic spring, but then they have a coil spring here. oh, this might just be like a helper coil spring. Okay, not sure if this, let's, can we check this website maybe? Oh, this seems really interesting. So is this the free, okay, this is the Koenigsegg free valve system. Okay, but yeah, so this, this cylinder head stuff, so this is not smaller than what like a traditional, and yeah, you have those like huge overhang stuff here on the back, and you have overhang at the front also, so like a traditional cam type system with valve return spring will be more, can be made more compact than this free valve test system. I mean, this is the thing I remember seeing, yeah, so I think they have the dual like action type, so you have one exhaust valve going into the turbine, and yeah, one going just bypassing it and going straight into the exhaust. So then you can get rid of the yeah, waste gates and stuff like that. You just can open the valve or the yeah, or direct more exhaust gas flow like bypassing the turbocharger into the exhaust directly, so you don't need a waste gate for that. But yeah, then again, you end up needing more valve area per bore, so yeah. But yeah, I mean, definitely a super interesting technology. And yeah, definitely, I mean, following along with this, but for like super high RPM stuff, not really sure. I don't think this will be able to do like as high RPM as we, I mean, I don't think you're going to be able to do like 20,000 RPM or something like that, but it might be possible. I mean, if you, because yeah, you can do like a pneumatic valve opening like things very quickly if you can build a valve that opens quickly enough to like allow the airflow basically to act quickly enough, which actually might be the bigger problem there. But yeah, not sure, but definitely, yeah, very interesting stuff. And yeah, I think we've basically gone through, so maybe yeah, the idea is more to go through what is currently available than try to do like future predictions and stuff like that, but interesting stuff. Okay, so it's a stock sub engine, otherwise it's not no space. Okay, so that is actually, yeah, interesting point of view there, Derp. So yeah, it might be that they want to fit that on the stock block and need to like seal against the factory like a valve cover, so that might be why the valve cover on that Saab engine is like basically factory sized on the like exterior perimeters there, because it needs to fit the engine there. Okay, and yeah, that might of course be much more efficient to like test longevity of parts, is to just use like a ready built engine and have all the rest of the car basically compete, and then just stick a cylinder head on there and test the cylinder head components, instead of like doing your complete own full engine with all kinds of other stuff, and then you need to build a car to test that in. And yeah, might be definitely more efficient to do that. Okay, good stuff. But I think that's everything. Hopefully I haven't forgotten about someone's comment. It wasn't too bad in width, although okay, yeah, so that's referring to other types of valve things. Okay, so yeah, that's it for Poppet valves, and yeah, we'll have to see. So this might be the second and last episode. I'll need to check and see what the response for this video is, sort of closer to the end of next week, sort of Thursday, Friday-ish probably will be. We'll be deciding if we're going to do a new episode on the weekend or not, or if we are trying to do maybe like a real video where we actually like think through things and have like more things like readily done and stuff like that. But I think this is sort of more fun to make anyway, like just discussing stuff live and seeing comments and suggestions and stuff, because yeah, there's so many things to like that. Yeah, I mean, it's not possible to follow absolutely everything that happens in the world, so we'll have to see what happens with that. But I mean, so yeah, so sorry, Joseph, I mean, it's not necessarily the last episode. I mean, these are fun to do, and I would definitely prefer to do these, so really like these, and there are like so many different topics. You can do probably like 1,000 different topics, like regarding all kinds of different engine components, and technologies and like maximum efficiency stuff, maximum RPM stuff, all kinds of bearings, connecting rod designs like I-beams, H-beams, all kinds of hollow connecting rod things, and yeah, different types of pistons, and yeah, I mean, just basically absolutely everything, like all kinds of intake runners and shapes of bell mouths and different types of plenum designs, and of course then if you start moving over to Cortex stuff, then yeah, I mean, it's like completely endless opportunity of different topics that are, lots of them are very, very interesting to look into, that probably lots of people know. But yeah, so I'm not saying that this is the last episode, but I will need to check and see, like, if there really isn't enough interest to warrant this, then well, we'll have to see, I mean, if we continue with these or not. But it is very, very interesting, so we are maybe willing to take like a small hit and like viewers or something like that, because it is fun and beneficial, I think, so might want to do that. Oh, okay, so derp. Oh no, that's apparently not in Finland at the moment, like somewhere where there's a warm sunshine or something. Oh no, yeah, I need to get some stuff going and working on some large motorsport track somewhere. Oh no, that sounds really interesting. Okay, but yeah, thanks for stopping by, derp, and have some fun there with your beers. And yeah, hopefully see you in the next episode also, if we do an episode next episode. I mean, hopefully we do, but we'll see. John Newman, oh yeah, on the most recent released image of the ER8, is that bulge on the bonnet for the intake? Yeah, that is correct. So we do have a power bulge there. Actually, the original Opel GT so does have a power bulge also on the let's actually show you guys what. Oh crap, how am I going to do this without okay, I think I figured out how to do this without, because yeah, so if I open my Twitter YouTube doesn't like what we have on Twitter, so yeah, that is going to result in an insta ban of this stuff. So but I hope, please don't open Twitter, please don't open Twitter. Okay, so this opened Twitter, but it opened, okay, I think we're good. Whew. Okay, so we didn't get banned. Great. This was a little bit sketchy, but oh well, we do have a 10-second delay. So okay, so if there was something like non-YouTube material here, I could still like, yeah, cut the stream before it goes. Okay, so okay, so there was like always a backup. Okay, so he's like talking about this. Wait, oh no, I need to move out of the way here. How do we do that? So I need to unlock this, and then I'll just scoot over here, I think. Nice. Okay, so moved out of the way. So this bulge here, so this is for the intake manifold. So the like hood or engine component top here, so this is extremely low. It's like right above the cylinder head, and because we have the engine tilted over, wait, so in the picture it's like tilted over this way. Okay, so yeah, it's tilted over this way, so we basically have the turbocharger over on this side. Wait, so no. So the engine this is really difficult when everything is like the wrong way around. So the engine is tilted this way, and the engine compartment, that is to make more space for actually having large turbocharger over on this side. So basically the turbocharger is over here on this side. So we want to package the engine bay really, really tight. That means the intake manifold, so we still want to have a good intake manifold with like good intake trumpets and stuff like this, so we don't need to deal with like large cylinders, 2-cylinder variations, and we want to have like a good VE so that we don't need to, so we have very good like off boost power in the engine. So that ends up making that the plenum does have like a reasonably large diameter. So this is basically the plenum shape, like sticking out a little bit. It's not like really optimized around that, but it's sort of a placeholder basically for the shape for the plenum. So it is like a full mid-engine setup basically. The Opel GT does have the engine like really far back compared to the front axis anyway, and we've been able to push that backwards a little bit more because yeah, we don't need any clearance behind the rear of the engine. The engine it just bolts directly through the firewall actually, so we don't even have bolts in between there, but the bolts for the engine mounting go through from the inside of the car through the firewall to mount the engine to the chassis really, so it's like as far back as possible. And yeah, so it's basically it is in fact a mid-engine, so there's no part of the engine that sticks out in front of the front axis of the car. So yeah, this is for the plenum there. Okay, yeah, really happy to go through the different materials and stuff. And it's always like a big like overall. Well, let's actually get some like let's get some Poppet Valve stuff back here going, so that so that the end screen doesn't end up being a ER8 race car or something and people get confused. Okay, so thanks John Newman for stopping over, and comments and questions and stuff like that. So material selection is always like a question of multiple different things. So what kind of a strength do you need? What kind of flexibility do you need? What kind of stiffness do you need? And and then operating and at what kind of different temperatures do you need these different parameters? So they will all affect what materials you want to use. But I think that's pretty much it for Poppet Valve stuff. And so trying to focus mostly on Poppet valves and not going through like how that affects absolutely everything else, like valve sizes relation to other things and stuff like that, is something we haven't gone through really. I think that would more be like engine parameter tuning or something like that. So but okay, thanks everyone for stopping by, and we got some really solid, very good questions, and incredibly helpful also on the information there, especially derp like checking the Koenigsegg stuff on the side there, and letting other people know what they were going through there. So thanks very much for that. I mean, hugely helpful. And for the other guys also commenting on what to look through and stuff like that. So thanks so much. I mean, I learned a lot. Hopefully you guys learned a lot also. And so again, a disclaimer, just throwing stuff out. I might be wrong on multiple topics. Hopefully I get most of it right though. So but anyway, that's it for this episode, and if we do another episode, hope to see you guys then. So thank you and goodbye.